Hello, everyone, and welcome to today's webinar, Rethink High Content Screening, Part 1, Why Old Technology Doesn't Cut It in the New World. I'm Cristina Ortiz, and I'll be your moderator for today's event. Today's web seminar is presented by LabRoots and brought to you by Araceli Biosciences. To learn more, visit aracelibiosciences.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit them if you have any technical issues in the same box, if you have any trouble seeing or hearing the presentation. I'd like to now welcome our speaker, Dr. Maggie Vantangoli Policelli, Director of Marketing at Araceli Biosciences. Maggie, you may now begin your presentation.
Awesome. Thanks, Christina, and thanks everyone for attending our webinar today. We appreciate you taking the time. So I'm going to give you a brief overview of how we at Araceli have decided to rethink high content screening. So we're going to talk a little bit about the high content environment and then move into what we identified as key opportunities to address bottlenecks in the workflow. We had, and we'll talk about this in a few minutes, we had a really unique opportunity at Araceli to start from scratch on our platform. We knew it was possible technologically to build a better system, and we didn't have a reason not to. So today we'll cover a bit of our path and how we at Araceli are rethinking the high content screening workflow, technology, and greater space. So it's worth noting today, in the time that we will complete this webinar, so approximately an hour, on an Araceli platform, we would be able to acquire more than 9,000 wells of data, analyze that data, and produce graphical visual results for any user on all of that data. So that is representative of more than 1536 well plates in 4 colors. So just keep that in the back of your mind as we talk about the advances in high content that we're working on at Araceli and providing at Araceli. And as Christina said, please share any questions you have in the chat. So laboratory innovation over the last 20 years has really sped things up in multiple different environments. Obviously, there's been a huge revolution in genomics. High throughput screening really is high throughput, right? So with high throughput, you get an ability to assess the effects of compounds, but generally that's tied to one or a very small number of data points for every specific assay or sample. On the other side of that, we have genomics, which generally is looking at a whole genome's worth of genes, but usually with one donor at a time. Obviously, there's techniques to pool. And then we have where we like to live at Araceli, which is in automated imaging. And with automated imaging or high content screening, traditionally, you're looking at thousands of variables measured per cell, but it's very, very low throughput. So what we have built at Araceli is the ability to make high content screening, high throughput screening. Many of the assays that users are used to using in a drug discovery lab or a drug development lab are those high throughput assays where you're getting answers and results in seconds to minutes, whereas oftentimes high content workflow is giving you results and taking more than an hour to scan your plate and then an additional huge chunk of time to analyze that data. So it just doesn't really fit currently with the expectations of many users in that environment. So these techniques for high content have been generally stagnant for quite some time. And this is also a space that's rife with bottlenecks and problems. So we accomplished at Araceli what no one else has done and built a high throughput imager, but we realized that is not the full solution. It's not just sufficient to take more data faster, right? So the question we often get from customers is, okay, great, you can take more images, but what do I do with them? That still doesn't solve the next bottleneck and the next bottleneck. So you can see on this graphic here, this is a really simple representation of a generic high content imaging workflow, where you have sample prep, you have imaging on the high content instrument, you have a desire to do some quality control of those images, then you run your feature extraction analysis, you have to deal with data management, you have to move the data, and then oftentimes you're doing some type of data mining or statistical modeling downstream. So the sample prep issue of generating enough samples for high content has been addressed by the industry. There's numerous liquid handling modules out there. There's an ability to generate now a lot of samples. So the next bottleneck has been the ability to image all of those samples. With that, there comes problems. If we address that bottleneck, the next bottleneck is going to be on the quality control. How do I know I'm taking good data? How do I analyze all that data? Because it's not sufficient to take a full plate's worth of images in minutes and then still have to spend hours and just push that backlog downstream. So we chose not to just look at the one bottleneck of imaging, of the actual time to acquire data. We've addressed that issue, as we'll show you today, and we will also show you some snippets of work that we're doing at Araceli to address the other parts in the workflow. As part of our, one of the real benefits at Araceli is we have been able to build this platform from the ground up. And we have looked at every single part of this workflow with scientists that are using this in their day-to-day work. And like I said, while acquiring data faster was a major concern, there are lots of other bottlenecks we have had to address. And so it's worth noting that our current platform addresses the imaging bottleneck, right? So our hardware offering, which we'll talk about. But then these other bottlenecks downstream, we're addressing those with a new exciting launch next year in early 2023. So what this looks like for users in kind of the traditional high content workflow is you've always had to make compromises. So we have, our little triangle of compromise here on the slide, where, you have speed, image quality or resolution, and sample coverage. So we define sample coverage as the amount of a well, like in a multi-well plate, that you can acquire in a high content experiment. So traditionally, you could usually pick 2 of these, but you never got all 3 with traditional high content imaging. You could acquire data really fast and get full well images, but you were using a low magnification objective that you didn't convey additional resolution or any kind of improved resolution. So that was always sufficient for doing nuclear counts, general morphology assessments on bigger structures, but it was not something that you could get subcellular resolution at high speed and full well. The flip side of that is if you wanted to go fast and image at high resolution, you only had 1 or 2 fields per well and they were tiny. So you really didn't get a robust sample number or representation of the sample within your assay. Finally, if you wanted to go get your full well, you were looking for rare events and you wanted that image resolution, you were talking hours upon hours to scan a plate. And we had, in my time in this industry, I've seen a lot of people doing that, and scan times of 6+ hours per plate are not unusual for those types of approaches. So we really chose to go after this problem of having to compromise and pick between these different points of the triangle with our platform offering at Araceli. We also kept hearing that it was hard to use. There was a lot of training burden for customers. And we'll share some more on this later, but a number of our customers have told us that it can take up to a year to bring a scientist up to speed on all their platforms, because typically they're not just doing high content. They're not just using one type of high content system. There's different systems within a lab. So it's a constant cycle of training and retraining people, because as soon as they get trained up, they leave. So because we didn't have to fit a pre-existing software architecture or framework or something that had been around for a long time, we really took the opportunity here to start fresh and design the best tool and offering for the job of the scientist that is using our platform. Finally, the biggest thing that we hit after was how long it took to get accurate data. So this wasn't, like I said before, wasn't just a matter of acquiring data faster. It was acquiring quality data that you knew was good quality faster and getting to your time to results faster so you could do the next study, the next experiment, the next thing that you have to accomplish, and really reduce that cycle time. So low quality data analysis makes you have to revisit data, setting your pipeline back even more. And segmentation errors propagate throughout your entire data analysis pipeline. And even if people don't realize it doing high content, you're constantly making decisions using traditional segmentation methods on what is good enough, right? So traditional workflows have you set your image segmentation parameters on your positive controls and your negative controls. And typically you have to make a call as to like, what is good enough? You're going to miss a cell. Is that okay? You're going to miss this puncta. Is that okay? And people all throughout that process, you are making decisions that impact the downstream quality of your data. It might even just be subconscious bias, but at the end of the day, you might be missing a whole population of cells that because you didn't acquire it or because you didn't include it in your analysis could skew your data in a different direction. So we really wanted to focus on delivering high quality results in a simple to use interface that were impactful for our customers. And we didn't just want to think and get stuck in a group think mindset at Araceli. We wanted to make sure that what we were bringing and what we thought were problems in the field actually were. So we asked people, and we, I'm not going to read all of these to you guys, but we constantly kept running into people wanting to do high resolution imaging much faster, wanting to take advantage of high resolution to do techniques like cell painting, right? Phenotypic profiling techniques, wanting to go faster because of the demands of cell painting, which we'll talk about in a little bit, and needing to train their users in something that wasn't going to take them 6 months to a year. It was something that could be walk up. They had confidence that anyone in their lab could walk up and use that system and acquire good quality data. You don't want to have someone cut loose on a system, have them start acquiring data, and then find out 2 weeks down the road, a month down the road, or even later that the data that they have been acquiring is garbage. Right? The exposure wasn't high enough, the settings weren't quite right, there was some problem with the staining patterns. So we took this to mean that we needed to start fresh. We wanted to take on these big problems that we knew hadn't been addressed in the last 20 years of high content systems being on the market. There have been incremental improvements over the years with the addition of CMOS cameras, of LED light sources to improve, 5% throughput here, 10% throughput here. But in reality, we are still all living in a land that there hasn't been a major technological shift outside of putting a microscope in a box and enclosing it and automating it in over 20 years. We knew, based on all of our research and our experience doing high content, that there were huge bottlenecks and speed constraints. And we also knew we could actually be the ones to do something about it. At Araceli, we weren't tied to a platform and a box that was already manufactured. We weren't tied to a software architecture that meant that we had to stick within a framework and not go outside that box. And we also weren't tied to just the mindset of we've always done it this way, so we're going to keep doing it that way. We kept hearing over and over again from everybody to make, we need to make this easier. I need quality control tools that I just know my data is good quality and I just need it to be fast and easy. If we think about just consumer products in general, anybody can pick up an iPhone and figure out how to take a picture. That was our unifying goal with the Araceli platform. So what we are talking about today is covering the vision for high content screening that is the core of Araceli Biosciences and what we've brought to the market. We are focused on delivering phenotypic profiling at high throughput speed. So we're not talking an hour, maybe 30 minutes to scan a plate. We are talking every plate under 10 minutes, full well, 4 colors. That is our goal. That is what we bring. We are approaching those and bringing the high content screening workflow into that high throughput state. We really believe in giving people confidence in their data. We want that data to be interpretable. And we also know that the traditional image segmentation workflows that we've all relied on for years can be better. With the huge improvements in computing power and the massive field shifting changes with artificial intelligence, machine learning, deep learning networks, we knew we could bring something to the market that was way faster and higher fidelity than anything out there in the market right now. That would really be transformational for our customers. So what does that mean, right? So what is the value and why bother? It's not just about speed, it's about getting higher, better quality data. Today, with the Araceli platform, high content is high throughput because we can do whole well, high resolution multi-channel imaging in under 10 minutes. And we've built the analysis to be faster too. So what this means is, when we're talking about why does full well matter, or why do I need to go faster? It's because all of the major techniques right now and the kind of shiniest, newest techniques in high content analysis are all looking at feature extraction in bulk, right? So it's not just the days of, is my nucleus green or not? Is my cell green or not? Which those assays work beautifully on Endeavor. We need more data. We are living in the time of big data. And what we know is more data isn't always better, but more quality data is better. And that means faster or acceleration of pipelines. That means your ability and your scientist's ability to make better decisions at the bench as to what the next experiment should be and not have to wait 2 weeks for analysis. And we're also seeing a huge increase, not only in cell paint type assays, but in the need to do and look at rare event biology. So you might have one cell in your well that is your positive that you need to characterize. Maybe it's a quad label or tri-labeled cell, and literally out of 1 million cells, there's only one. That means you need to capture the whole well. And you shouldn't have to wait 6 hours for your plate to scan to do that at the resolution you require. Because that, if you don't, you might miss that candidate. What if you miss that option? If you're not capturing the data, you can't know what the data includes. So the value in the full well is really giving you confidence that you've looked at everything and reduced error bars, right? So you're not subject to, if you're only looking at samples in the center of your well, any type of plate washer or staining aberration that's altering morphology of the cells, you're looking at everything holistically. So we think of the Araceli platform as the ideal cell paint solution due to the throughput of the platform, but we can talk more about that as we go on today. So when we think about rare events, some of the work our customers have been doing is simply looking for a rare mitotic event. It could also be those quad labeled cells. So oftentimes when we tell people that we are doing full well imaging, they think of us as just another, okay, well, I can count nuclei, that's fine, but this slide can really show you the power and the resolution we deliver at Araceli. So not only are we doing full well imaging and capturing all your biology, but we are able to tease out mitotic spindles, and we can analyze those with our downstream analysis tools. It's not just, let me tell you what size my cell is. We can look for these mitotic cells outside of this whole population. The way we did that is we built the optimal optical path for high content. We chose to go for high resolution with a large field coverage that gives you speed and resolution. So one of the common questions we get is, what magnification is it? And honestly, our system delivers 0.27 micron pixel resolution, and we have the range of magnifications that everybody wants, right? So in traditional high content, you'd always talk about I need a 4x, I need a 10x, I need a 20x lens. If you're getting the full well at high resolution, you don't need it. We give you that every single time. Every single plate that you put into an Endeavor or Araceli platform, you end up with this type of resolution. So another example of this, sorry, I got a little stuck here. There we go. Another example of this is a 96 well full well image. And this is showing you that we acquire this whole well at high resolution, and we can clearly define subcellular features like DNA damage foci in this example here across that whole well. And you're not making a sacrifice to get this. So this whole plate in these 3 colors was acquired in about 7 minutes. That's it, right? So it's not, you know, if you only want to acquire a subset of the well, we could do that in about 30 to 40 seconds for this example. But, you know, if it only takes 7 minutes to acquire your full well, why wouldn't you, right? So we really, really believe in giving you all the data and all the information from the cells that you've worked so hard and spent all your money on to prep. So we're talking about a platform that delivers outstanding image quality across the whole well. And we've benchmarked our throughput. We've talked about this, you know, because people will always say, you know, it's high resolution, but obviously you only do that if you know, look at a lower resolution image, or, you know, there's no way you can hit those speeds. How do you do it? Because we realize that we make very, very bold claims at Araceli about our capability and where we are compared to where high content has been for a long time. So we have benchmarked our throughput, and we've done this time and time again. We've done this with customers. And what I can tell you is we have the ability to scan a 96 well plate in 4 channels with laser autofocus. There's not like all the caveats here that oftentimes these speed specifications have. And assuming a 10 millisecond exposure per channel, which is pretty standard on our system, you can acquire 96 well plates in under 7 minutes in 4 colors for full well. That translates to 183 96 well plates on 1 high content system a day with automation. But more importantly, and where we really see people get excited, is that with 15 36 well plates, we can do those in about 9 minutes. And that translates to 140 15 36 well plates on 1 system in 1 day with automation, assuming a 24-hour runtime. So this is way beyond anything that's on the market right now. And this is why we are high throughput. So we're able to give you all of that contextual data from a cell-based imaging assay in this time that it takes you to do a traditional, you know, fluorescence intensity measure or plate reader assay in those kind of more traditional high throughput screening environments. So we really, really believe in tearing down all of the kind of gatekeeping of high content that's existed out there in the market. And one of the things that begs the question is, well, is the data you're acquiring high quality, right? So, and this is not just something that we hear from Araceli. This is something we've heard from our customers from forever. You know, my previous roles, I was always out supporting customers and training them. And it was always a question, well, how do I know my data is good enough? How do I actually know? So we took that feedback and we put effort behind making sure that you're not going to analyze bad data. We are going to make sure that analysis is worth your time before you do it. Even though it only takes a few minutes, it's still the right thing to do. So we have the ability within our platform to flag data that is either out of focus. You can see in this example here, there's some in the upper left-hand image, there's like a speck of dust that's slightly above the focal plane that's throwing off the image. We can flag that with a quality metric score. So anything red here closer to 100 is a better quality. Anything reduced from that is lower quality. So we can see on this full representation of our 96 well plate here that we have some wells that are questionable, right? So there's probably dust on the bottom. Maybe there's debris in the wells themselves, like the example in the bottom left. So we have the ability to flag that, and that's seconds for us to do. We're not talking this is another huge, massive step of your workflow. This is something that is almost real time for the images. So you can know right away if you should analyze this data. And we're not just flagging things that have debris or have like focus quality issues or dust or scratches on the bottom of the plate, because that's important. We can also flag whether there are tip strikes. We can understand and determine whether there has been a staining problem in a certain well. And I don't have the data in the presentation today to show that, but we're not just talking like a one-trick pony that can flag one thing and move on. So we've really, really focused on making sure that you should be able to filter your data. And also, if your data needs to go work, like, do you want to have that taking up storage space? Do you want to have that just sitting on your drive? Should we go back and rescan it? Is there something we can do to salvage that sample? So this is super critical when we talk about our analysis workflow as well. So our focus is just making sure that our customers have peace of mind. So that is true for data quality, that is true for our analysis, which we will cover in a moment, but that's also just true for our acquisition software. We have made the decision, and because we've been able to start over from scratch on the platform and build it from the ground up, that we wanted to make a simple and easy to use acquisition software. Everybody says it's easy to use. Their platform is easy to use, it's simple, and we just have people try it, right? So our challenge to everybody is that we know we're making bold claims. Sign up for a virtual demo, come see the system. We're able to show this to anybody and get you trained in 15 minutes or less. So we really designed this from the ground up to be able to control the complexity of the software. Every single decision we made and continue to make about software design is made in the context of the end user and what the job is that someone needs to do and move on to the next thing. We do not want this system to become something that someone has to spend their whole day running one single plate and getting through the software. It's just another piece of the workflow for our customers. So that begs the question, if we can scan in under 10 minutes and generate all this data, what happens to it? How do you get actionable, interpretable data from that? So we have, launching in Q1 of 2023, our new image analysis solution. So we've chosen to move away from the traditional image segmentation toolbox of pre-processing and allowing users to just kind of set thresholds based on size and intensity, because we all know that can be problematic for for a number of assays, and you're always making biased decisions on what is good enough and what isn't. So we have built a platform that is working off of all the latest and greatest technology in the artificial intelligence space. So we utilize deep learning, we utilize machine learning, and we offer neural networks for detection. So our deep learning does the work for you. And we have trained the algorithms to distinguish biological features in any environment. We are the experts on high content, on image analysis, and we've built that into our product so that our product become your image analysis expert. So our algorithms have been trained to distinguish those features, and what it means when they've seen it all is we have trained on enough sets of biological features that new things often will just work, right? So you're not stuck in this. One of the fears I've seen a lot of customers have around artificial intelligence in general is this perception that you have to train these networks for hours and days and weeks, and it's tons of clicking, and it's almost diminishing returns. And how do you know when it's good enough? And how do you know if it's good enough? Or how do you know if you should train more? And one of the things that we've built into this product is the ability just to go, right? So we've taken that on and how we've built our product and how we deploy this to our customers to make sure that you're not sitting there doing training. It's just going to work, right? And if you need additional help, we can do that. We offer data annotation service or data science services, but it is so simple that people can just do it. And the most important thing here is that it was absolutely critical that we built this software to keep up with Endeavor, the hardware offering. We were not going to accept something where we can scan a plate in 7 minutes, but it takes 3 days to analyze the data. So we're talking something that we are compressing that entire workflow down into minutes compared to hours, days, or months from previous iterations of high content. And here's some proof of that. So this assay this is an example assay where we were just looking at puncta analysis. This is a 1536 well 2-color assay with a nuclear stain and a puncta stain in a separate channel. And this assay was looking at puncta morphology, puncta counts, and intensity. And we were able to conduct that full plate single well analysis in 3.5 minutes. And that includes the segmentation, the feature extraction, and the plotting. So it's worth noting on this assay, we benchmarked this against Cell Profiler on the same system. And Cell Profiler took an hour to run this plate. But it is worth noting that the pipeline development by our experts took a lot of additional time. And those are people that have used Cell Profiler extensively. And this is not a knock on Cell Profiler. This is just saying that Voyager can keep up with the data. Our platform can keep up with the data that is generated by Endeavor. And we're talking results in minutes. So for this assay, it took us 7.5 minutes or so to scan this plate. And it took another 3.5 minutes to run the analysis. 11 minutes to, endless numbers of data points is a game changer in the high content screening space. So this will be launched at SLAS in 2023. So if you'll be there, please come by our booth. If not, you can, hang out virtually with us too, I'm sure. So we're really looking forward to seeing and sharing this with the greater high content screening environment and community in the first quarter of next year. So in summary, what does all of these improvements that I've shared with you today mean in the actual context of a lab, right? So, if you're a lab where you just need to get through and crank through an immense amount of plates, this is the platform for you. So we acquire data we can run screens in hours or days, not months. And that context of that screen could be, 100 plates. We can run that in a day on an Endeavor and we can analyze it. That for other types of setups, that could mean instead of having one user take up your system for a day running all their plates, you might be able to get 5 users in and run all their plates. And most importantly, this is an accelerated decision cycle. We're not just speeding up the imaging, we're speeding up the imaging, the analysis, and we're allowing people to make a decision. So to move from the biology in a plate to a decision on the biology in 10 minutes or less. And this decision cycle it's compounded and it's cumulative. So it's cut down for every single step moving forward for your organization, and you're saving hours every single day. So in general, your return on investment for the platform is paid with the acceleration of results, the acceleration of findings, and the ability to make better decisions faster. So overall, we definitely have rethought high content, and we've reimagined high content from the ground up. So we have built an ultra-fast imager that is capable of providing phenotypic profiling at high throughput speeds. We have a system that brings that power into your lab in a way that doesn't require your team to get trained for weeks to months to taking up to a year to get trained. It's minutes. And this is something that can deliver confidence in your data with interpretable results through our quality control, from everything from our quality control metrics to our analysis solutions. It's important noting that we are constantly innovating, we are constantly adding to this capability, and we are just super, super excited to keep sharing this with the larger field. So like I said, we will be launching our image analysis solution at SLAS in 2023 in beautiful San Diego. But we have some ability to show some stuff behind the curtain right now. So please reach out to us if you have questions. And overall, what our platform is, what the Araceli platform is our high content screening platform is made up of Endeavor, which is our hardware offering, our new analysis software coming very shortly. And we also offer the ability to scale the Endeavor with our automation solutions. Endeavor can also be integrated with other automation solutions. But the best thing to say is we have made some really, really bold claims on this webinar. We've, said that we can do in 10 minutes what it takes other systems to do hours. And we recognize that that is a huge shift, fundamental shift in the space of high content imaging. So I would advocate for all of you to say that the best thing to do is come see it, whether that is at SLAS in the US or Europe next year. There's some other conferences we'll be attending, or our live virtual demos. We are constantly offering those, and we encourage you all to come see it for yourself. And then follow us on LinkedIn, Twitter, Instagram, or sorry, not Instagram, YouTube. I swear to God, I know my social media channels. And then it's worth noting that my webinar went a little bit faster. So I think, in the time that we've given this webinar, in about 35 to 40 minutes, we've got Endeavors that could scan probably 5 of those 1536 well plates, so a little bit closer to like the 7,000 wells, but I still think that's a huge improvement over barely making it through the first quarter of a high 1536 well plate on any other system on the market. So with that said, I just want to give a quick thank you to the Araceli team for all of the support in getting this webinar off the ground, getting the product off the ground. Christina, our moderator, has been phenomenal and helped, not just moderating. Matt Boive on the Araceli team has been essential for generating a lot of the beautiful images that you see in this presentation. And then, of course, Mike Shostad has been a critical member of the team, helping us get this off the ground. And the larger Araceli team, we're always super excited to go and share with you and get the best pulse and the best feedback from our industry. So at this point, Christina, I think we're ready for any questions that the group might have.
Yes, thank you, Maggie, for your informative presentation. We're going to start the Q&A section of the webinar. So if you have any questions now, please click on the Ask a Question box located on the far left of your screen, and we'll answer as many questions as possible with the time being. So let's get started with our first question. So how does your artificial intelligence and machine learning based analysis differ from traditional methods?
Great question. So many ways, but overall, it really depends on the method. So it's worth noting, and I think I didn't share this on the discussion or on the webinar is, number one, generally it's very fast. So oftentimes we can acquire a plate actually faster than we can acquire the data, significantly. And we have our number one goal for analysis will always run as fast as acquisition, but oftentimes we are much faster than the acquisition. So number one is speed, but versus traditional methods, one of the most critical things is that what we found is having just one tool in your toolbox is not anything, that is not where anybody wants to be, right? Where you have one thing that you can do and do it well. And our analysis platform is built in a way that we have the best tools for the job. So traditional image segmentation is one tool, and it does not work for every assay. Our offering is built in a way that we have deep learning, we have machine learning, we have some other proprietary ultra-fast methods for doing image segmentation and feature extraction and analysis that our goal is to bring and design this platform in a way that someone can just use the best tool for their assay. Some assays, you might not need all the intricacies of a highly trained deep neural network. And you might not want that because it might take a little bit longer to run. You might want something that you can run in 30 seconds. And we have a tool for that within the software. So basically, overall, the overarching difference between AI and ML and traditional methods, and to simplify this very quickly in the image analysis space, is that with traditional methods, you often have to set things using either a threshold for size or intensity. And if there's a difference in intensity in a different well because the staining wasn't good enough or something happened or there's just a little bit of bleaching, you might miss a complete well's worth of data. You might just throw that. You never analyze that data because you're only looking at, a couple parameters for what determines a cell. With these AI-based approaches, you're looking at what a cell is. It's the difference between saying an animal with 2 pointy ears and 2 eyes, okay, is that a cat, is it a dog, versus saying, I'm looking for a cat. Give me a cat and show me the pictures that are a cat. That's the biggest difference.
Awesome. So another question we have is, what technological advances have you made that make your system so fast?
It's a great question. Everything. So when we designed Endeavor, we really started from the ground up. The traditional high content methods were awesome and they were game changers in their time. But we decided not just to take another microscope and build a box around it. We really looked at every single part of what constitutes an optical path, what constitutes the computer that runs the system, what constitutes the analysis software. And we looked around, not just within life sciences, but other industries where speed and throughput are essential for work. We redesigned the optics and we're using the fastest available hardware to ensure that we can acquire data at ultra-fast speeds. We've also taken every possibility to streamline and parallelize within the system and within the software.
Awesome. And then you mentioned automation in the webinar, but what automation options do you offer currently?
Yeah, so we, on the previous slide, we have a listing for our Endeavor GT option. That is a hotel and arm that is controlled by or sold with Biocero's Green Button Go control software. So that's really designed for users that just want to buy the full package and get started. This also fits into existing workflows. We have, we like to use the CLA 2 interface for device connection, but basically any capability that you have for automation, we can get Endeavor working within that with, kind of the typical driver feeder type of workflow. So anything that's working on your current high content system, just a matter of plugging this in instead.
And then another question is, how big is the instrument? How much space would it take on a lab bench?
Yeah, great question. So Endeavor was built to be, it's roughly a 26-inch cube. So it's 26 inches wide by tall by deep. But it can fit on a 24-inch depth wide bench or depth bench, sorry. So it can go on to 24 inches, but it's certainly not as compact as a plate reader, but it is also does not take a full lab bench or, a full room or something along those lines.
Okay, awesome. And I think that's all the questions we have so far.
Christina, I see there's one other question. I think it raises a good question. I think it's worth addressing on running 3D4 and 1536 well plates for 3D models. We have run some of those tests. So there's a question in the chat, let me reiterate that, that says, have you timed running 3D4 and 1536 well plates with 3D models that require Z-stack images? Yes and no. So I will give you the caveat that the speed always depends on how big the things are that you're imaging. What I can say is it's not surprising if you have to acquire more images in Z that the system goes a bit slower, but it is still way faster than anything else out there. So we've done, some 5-slice stacks on 3D models with that would cover about like 10 to 15 microns we've looked at on, 3D4 and 1536 well plates. And that can take anywhere from, 20 minutes to about 40 minutes. It depends on a lot of the configurations, but it's still way faster than anything on the market. A lot of that depends on exposure time, but it is still designed to be ultra fast. We really like to stick down on that 2D environment just because it allows us to look at this and really embrace all the benefits of the Endeavor speed, but it certainly does translate over into the offering better throughput on those 3D models as well. It really depends on the biology that you're looking at.
Okay. Awesome. Thank you, Maggie. I think that's all the questions that we have today. So thank you, Maggie, again for your time. And before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions that did not get answered today, you can submit them during the on-demand period, and they will be addressed by Maggie. She will get in touch with you. And then this webcast will be able to be viewed on demand. LabRoots will send you alerts via email when it's available for replay. And we encourage you to share it with as many of your colleagues and contacts as possible. And until next time, thank you very much and goodbye.
Thanks, everyone. Bye.